Hello and welcome back to our data structures and algorithm series. In this video, we're going to learn how to delete a node from a linked list. Just like insertion, we can delete a node from the beginning of the list, that is deleting the head actually. Like here, if we wanted to delete node A, or we can also delete between two nodes. Like in this example, we are going to delete this node C, and we can also delete at the very end, that is, for example, node D. So in this particular visualization, I've focused on deleting a node in between, and particularly we are going to be deleting node C. So let's see how that is done. So in order to delete a node, we first need to find it. So we have to traverse the list. You can see the arrow that I'm having there at node A. So we have to move on to node B, then move on to node C, which is what we want to find. And indeed, we are there now. Now, once we are here, there are two things we need to do. The first thing is to change this pointer so that instead of the pointer on node B pointing to the address of node C, we now want it to point to the address of node D. So where do we have the address of node D? Of course, we have it over here on node C. So generally what we are going to do is to do something like b.next is equals to c.next, so that we can copy this 1044 to come here. So that is step number one after we found the node. Then step number two will be to delete this node C, and we delete node C in one of two ways. In Python, you can use the del command to delete an object, or we can simply point c.next to null, and it will also be deleted. So let's just continue and see now how that visualization works. So indeed, we are going to copy the address of the next node after node C, which is stored at c.next. So 1044, you can see that B now is 1044, and therefore the pointer for B now points to the last node, which is node D. Then we are going to delete that particular pointer to node D in node C by changing it to null. Then after that, we delete it. So that is how we delete a node that is in between two other nodes in a linked list. So let's jump right in Visual Studio and implement that. Okay, so inside the singly linked list class, we can just do a comment function to delete a node. Okay, so we want to do def, then delete in between, something like that. You can call it that. It's going to receive self and also the value that we want to delete. Okay, so once we are there, the first thing we're going to check is check if the linked list is empty. So we can just do if self.head is none, but then we can just return or print something, then return. So it's always good to print something. So print the linked list is empty, something like that. Okay, so after we've done that, we can now go ahead and declare variables to hold the previous and the current nodes. So we are going to do a previous. variable and just assign it to none, because initially it does not hold anything. Then we want to also create another variable called current, and we just want to assign it to self.head, to the head of the linked list. Then we are going to traverse the linked list as we search for the value. Okay, so here we can use a while. So while current, just like that, while current, while you still have a node and a current, we want to, for example, use an if statement. So if current dot data is equals to the value we are searching for, and then we want to do something here. So the first thing we want to do is to do previous dot next previous dot next. We want to equate this. Okay, we want to do previous dot next equated to current dot next, like that. Then we want current dot next to be equal to none. And here we can also do del current. We want to delete. So when we do del current, the garbage collector is going to delete that particular object from the memory and free up that memory space. Then we want to return, just like that. Then outside the if statement, we want to do previous is equals to current. Then we do current. We update current in every loop. Current is equals to current dot next, like that. Okay, so and then here we can just print if by any chance we get to the end of the loop, it means that that value was not found. So value not found. So we can just do here print the value. So that variable was not found in the linked list. Okay. So I think that is about it. I think our function is done. So we're just beginning from here all the way to here. Again, the first thing we are checking is if the list has anything, has any node. Then we are declaring a variable, the variables to hold the current and the previous nodes. Then we are traversing using the while. And inside the while, we have an if statement to check if the current.data matches the value we've passed the function. And if that is the case, then we're going to update the previous.next to whatever address is stored on current.next. So remember, the current pointer is always going to be ahead by 1 compared to the previous pointer. Okay, then outside the if statement, we have this, which is very important, still inside the loop, to update the previous to the current node, then update the current node to the next node. So that is how we are updating. Okay, wonderful. So let's try this out and see how it works. So you can just come here and call the function. So my singly list dot delete between. Then, for example, we want to delete C. Then we can duplicate this, Shift Alt and the down arrow. Then I can move it with Alt and down arrow so that we can print the before and the after. Then you can be able to compare. So I'll just save my work, then Control Alt N to run it. Okay, wonderful. So yes, we have the answer here, and you can see before we have the C, but in this other one we do not have C. So that is exactly what we wanted to achieve, and that is what we wanted to achieve. Okay, of course there are many ways of how you can do this. Let's try, for example, deleting something else, for example B, and we save and run. Okay, so again you can see that we've actually deleted B. So in the first one it's there, in the second one we do not have a B. Okay, what if we delete an A, for example? What will happen? So A is actually at the beginning of our linked list, so let me just clear this. Okay, did I save then run it? Okay, so as expected, you can see that we actually have an error on line 55, and the error is an attribute error. It is saying that we have an object that does not have the next attribute. So remember, inside the if we said previous.next, but previous, as you can see, let me just get out of that. If you can see here, we've said previous.next is equals to current.next. But what is previous? Previous is equals to none. So the first time we encounter this, before we encounter this, previous is not an object, so it does not have the next attribute. So that is really what this error is saying, that previous.next does not have the next attribute. It's not an object. Okay, so to sort this out, of course, I had just promised that we were going to delete in between, but we can also just explore how to delete from the head. Delete the head node. So to delete the head node, we need to use an if statement and check if self.head then dot data. So you guessed it right. If that is equals to the value that we've passed it, if it's equal to the value that we've passed it, then we can just create a variable current, then assign it to this object self.head. Self.head, like that. Then we can update self.head to be equal to what this head is pointing to. So that's next, like that. So if we just do this by ensuring that now the head is actually pointing to the next, to current.next, then we will have deleted, we will have skipped the previous head node, and we can also delete it, by the way. Okay, so with this, let me just save. So remember that we still want to delete A, so we want to see whether we'll be able to delete A after updating our code like that. So just run it again. We still have an error. Did I save? Yes, I did. On line 59. Previous to next. The same error. Not supposed to be there. Let me just check it out. Good. I actually typed this at the wrong place. Let me just cut that. They're supposed to come here. Okay, somewhere here. Good. Should be here. Okay, now I'll just save it. then try and run again. Good. Okay, so yes, this time you can see the first list has an A, but the second list is actually beginning from B. But we still have a problem. This has been run. The value A was not found in the linked list. So to deal with that, we can just introduce a return statement here. So we can just do return so that we get out of the function. Once this if statement has been executed, we will not continue to execute anything else in this function. So that is what that return will do. I'll just save it again, clear this, and then run. Good. So you see now we do not get this being printed. So really, let's also try out, are we able with this function to delete what is on the end of the list, so the tail. So let's just do F and then save, clear here, then run. Okay, so you can see that we have F on this one, but we do not have F on this one. So really, this function as it is can be able to delete from the head and also in between and also the tail. I hope you've learned and enjoyed. Thank you so much for sticking to the end. So in the next video, we will look at the stack data structure. See you then. Bye bye for now.